Okay, we're continuing with exercise 3.8, examples, question 13. Find the area bounded by the curve y equals x squared plus 2x minus 8 and the line y equals 2x plus 1. You need to do a quick sketch first, but before you do that, you might want to factorise. What have you got for the first one? X. So y equals, yeah, it's 2 and 4. Which way? Plus 4 minus 2. So therefore, this is a concave up parabola. Sorry. So it's a concave up parabola. X intercepts at 2 and negative 4. You must sketch it. So we've got X intercepts at 2 and negative 4. It's concave up. What about the Y intercept?
Please excuse this interruption. Could I please have a representative from Miss Minchenko's Year 9 Learn to...
Concave up. X intercepts at negative 4 and 2. Axis of symmetry would be at negative 1. Halfway between. I'm not too worried about where the y-intercept is, but it is at negative 8. Okay, because it's x squared plus 2x minus 8. That's that curve. Find the area bounded by that curve and the line y equals 2x plus 1. So sketching that line, I think I'm going to have to extend that up there. Just do a table of values. When x is 0, y is? When x is, I don't know, I would just do a quick... when x is 2, y is 5. I don't know. This is obviously not to scale very well. I'm just going to draw that it goes like that. Okay? But what you're going to need, now you obviously don't need this bit there. What do you need? What do you need? Yeah, the points of intersection. So you're going to have to solve y equals x squared plus 2x minus 8 and y equals 2x plus 1 simultaneously. So how will you do that? Just put them equal to each other. So put them equal to each other because y equals and y equals. Got it? Now what do? X squared is... Yeah, x squared is 9, so x is plus or minus 3. Because the two x's cancel. So therefore, this point of intersection is 3 something, and this point of intersection is negative 3 something. You actually don't need to know the y values, all right? I mean, you can put them in if you want. When x is 3, if you look at the straight line curve, y is 7. And when x is negative 3, I think it's negative 5. But you don't need the y values. All you need are the x values of the points of intersection. Now, how do we do the area between the two curves? Isn't it top curve minus bottom curve? So when you've got the area enclosed between two curves, those that missed the video yesterday or the beginning of the end of yesterday's lesson, this area is bound between two curves, so it's just integrate the top curve minus integrate the bottom curve. So the way we do it, the area between the two curves is the integral from which values? Between the points of, yeah, between 3 and negative 3 of the top curve, which is the straight line. So 2x plus 1 minus, sorry? Why would you do that? No, minus, so you do the area below. To do the area bound by two curves, the rule is integral of the top curve. See in this section how the straight line is sitting above the parabola. So you do the straight line minus the parabola.
Besides you have 3, 7 and 3, negative 5.
Oh, I solved simultaneously.
Oh, and then you see something.
Okay.
Yeah.
And put them equal to each other. And I got x squared is 9, so x is plus or minus 3. I don't actually need the y values. All right, so you really don't need the y values.
Yeah.
Okay, girls, note, can you just all listen, please? You can do it as two separate integrals. So I will set it up as 2, but I don't want to do it as 2. It's really the integral from 3 to negative 3 of the first curve. Actually, can someone pass me, can I have some tapey stuff? Yeah, that's it. No, you're right. I'm a bit entangled here. Actually, just do it as 1. Get rid of that. Oh no, I think it's stuck. Oops. No. All right, I've got one in my pencil recording that. Okay, so we've got integral from 3 to minus 3 of the top curve minus the bottom curve. Make sure you're taking away each of those terms in that second function that you've got there and combine like terms, and we've got minus x squared plus 9 dx. Now, if you would have done them all separately, you would have had to have integrated the 2x and the minus 2x, and you're doubling up on work. Actually, more than doubling up. You actually don't even need to integrate those 2x's because they cancel. So it's best to simplify where you can. The only time you would do this is when you're doing the area between two curves, because you're substituting in 3 and minus 3 for both of those. It's different to some of the ones that we were doing yesterday where the areas are side by side. Okay, so now we just integrate and substitute in those values. Negative x cubed on 3 plus 9x. Substituting in the values 3 and minus 3, or negative 3. And what do we get? Negative 27 on 3, negative 9 plus 27 minus, put it 9 minus 27. So it's negative 9 plus 27 minus 9 plus 27. I mean, you can work it out, but I just thought I'd expand it. No, it's not, actually not. It's minus 18 plus 54. No, because that's minus negative 27. So what is it, 36 or something? 36 units squared. So that's the area between the two curves. So please collect like terms only if you're doing the area between two curves, because you'd be substituting in the same values of 3 and negative 3. You don't need to do it as two separate integrals. So when it's different, when you're subtracting one function from the other, you can just do the one integral symbol. But when you're adding two areas together, you can't. You need to do them separately. Okay, now someone else has asked for 15 and someone else has asked for 14. So we'll have a look at those.
14.
Let's do 15 and then it doesn't have to be in order, girls. So I'll do 15 first. Ready? Can I turn the page? 15 in exercise 3.8, find the exact area enclosed between that first curve y equals 4 minus x squared, square root of 4 minus x squared, and the line x minus y plus 2 equals 0. What do you, tell me what you think about the question.
It's the area of the semicircle.
Yeah, the top one's a semicircle, and if you weren't sure, what would you do with this? You would square both sides, and you would see that you've got y squared is 4 minus x squared. So if you weren't sure what this curve is, because see, some people get confused as to whether it's a semicircle or half a parabola. And that's okay. So you just square both sides, and you can see that it is going to be a semicircle, the top half or the bottom half. Okay, what's the radius?
2.
All right, so we've got a semicircle, top, you know, sitting above the x-axis, radius 2. Now with the next one, you've got to be really careful. You've got x minus y plus 2 equals 0. What should I do with that? Let's put it in a nicer format. What sort of equation is that? It's a straight line. So make it look like one. I mean, it does. That's general form. Y equals x plus 2. So tell me, it's a straight line with y-intercept, gradient, 1. You know when the gradients are 1, if it's positive, if it goes 2 there minus 2 there, but we can substitute in values. So let's do some substitution. When x is 2, what's y? Oh, sorry. When x is 0, what's y? When x is negative 1, what's y? Positive 1. When x is negative 2, what's y? This is your straight line. So, and the shaded area is in between. See, you've got to sketch it. If you don't sketch it, you're not going to know which curve is above which. So, what are the x values of the points of intersection? 0 and negative 2. You don't need to solve simultaneously. We've already...
Miss, how do you know which side's already?
Oh, it's the area between the two curves. Find the area enclosed...
Can't the other side be on the...
No. No, no, no. Oh, no, because you don't shade down here because that's enclosed between the curve, the line, and the x-axis. It's not asking for the area enclosed by the x-axis as well.
It says on the x-axis you go from the blue.
If they wanted, they just want the area enclosed between the two curves. If you do down here, it is enclosed between the two curves and the x-axis down here. Do you see that? Like there's a curve, there's the other curve. If you shade in here, it's also bound by the x-axis, but they don't say that it's bound by the x-axis. It's just the area between the two curves. So, how do we do it? You need a few things. Which curve is above which one? And you need the x values of the point of intersection because you are integrating with respect to the x-axis. Yes, they're there in front of you. So the x-intercepts at the points of intersection are, you can see it, are 0 because you need to integrate. You need to do top curve, integral of top curve minus integral of bottom curve to do the area between two curves. That's how you do it. See, the reason we do that is, let's say you want to find the area below that semicircle bit. Oh, this is a bit of a bad one. Let's say I want to find the area below the, if I integrate below the semicircle, don't I get that whole thing? Watch what I'm doing. If you want the integral from 0 to -2 of the semicircle, don't you get this whole shaded bit? And what about the area? And if you take away the area under the straight line, take that away, aren't you left with just that? Yes. That's why you do the integral of the top curve. See, the integral of the top curve gives you all this. And the integral of the bottom curve gives you just down there. So if you do top curve minus bottom curve, you get the black lined bit. Do you get the idea? All right. That's why you do top curve minus bottom curve. Now, in example 13, top curve minus bottom curve was not all sitting above the x-axis. It does not matter. It doesn't matter. Part of it can be beneath the x-axis, it doesn't matter. So if you look at the example before, top curve minus bottom curve, you might say, but geez, some of it's below the x-axis and it's going to be negative if you integrate under here and that bit's going to be positive. It doesn't matter. When you do the area between two curves, it takes care of that and it sorts it all out in the integration. So it's always, that's the easiest one to do, top curve minus bottom curve for the area between two curves. Doesn't matter whether the curves are up here, whether the curves are down there. It doesn't matter whether they're below the x-axis, above the x-axis, or halfway in between. Now, guys, there's a problem. I cannot integrate. So therefore, the area between the two curves, isn't it the integral from 0 to -2 of the square root of 4 minus x squared minus the integral from 0 to -2? I'm writing them as two separate ones and I'll tell you why. From where? For which curve? The x plus 2 dx. Now, I can't integrate the first one. Isn't it the area, so we do this one minus that one. I don't have to put this integral sign here. I can leave it out and just go all of that minus x plus 2. But I'm not doing it. I'll tell you why, because I can't integrate the first one. It's not of the form ax plus b to the n. It's ax squared plus b to the n. So, how do what does integration do? Doesn't it just find area? So, what you want is basically the area. So, you cannot do this. This cannot be integrated. All right? The other one can, but why integrate this one when I can just do area of what? A triangle. So basically it's the area of the quadrant. The first one can't be integrated. Yes, I know the second one can, but while we're doing areas, let's just stick and do areas. So basically the area between the two curves, how do I do it? Isn't it that shape minus this one?
So you're just going to do...
Just do normal measurement formula. All right, so what are the dimensions? Oh, look, the integral will work for the second one. It will work, but why? This is quicker. So 2 and 2. This is a a quarter of a circle, a quadrant with radius 2. So how do we do it? Isn't it pi r squared, pi times 2 squared over 4 minus a half times 2 times 2, half base height. So therefore we've got pi r squared over 4, quarter of a quadrant minus the triangle will give you, if you do that, you'll end up with that shaded area. Got it? So please look out for those semicircles. You cannot integrate them, because they're trying to see whether you know what integrals mean. When you integrate, you're finding the area under the curve. All right, so what do we got? We got pi minus 2. That's it. Pi minus 2 units squared, which is 1.1 whatever. Please leave your exam answers as exact values. If you don't leave them as exact, at least show the exact form. If you feel like doing 1 or 2 decimal places afterwards, fine. But you must put an exact answer there first. Oh, they probably won't, but it's a good idea to put them. Okay? But you may lose marks if you don't write pi minus 2 and if you just gave me a decimal approximation. So if you want to give the decimal approximation, fine, but please, I'd prefer you don't. You don't need to. Exact answers are better. Often they're looking for an exact answer as opposed to the decimal approximation. If they don't ask to 2 decimal places, then leave it as an exact answer. All right? Okay. So again, this is area between 2 curves. What about question 4? This is question 14. I want you to attempt it on your own. I need a sketch. I need points of intersection. You need to know which curve is above the other curve. Okay? You've just got, these are very simple. One is just a concave down parabola shifted 1 unit up. And the other one, because y equals 1 minus x squared, is y equals negative x squared plus 1. Right? The other one is a concave up parabola shifted down 1 unit. So please sketch them. We need x-intercepts. They probably are going to cut at the x-intercepts. You can solve simultaneously if you need to, or I'd be trying to work out what the x-intercepts are. That seems to me to be the easiest thing to do, to find x-intercepts by putting y equals 0. You'll be able to see the answer straight away. Look, this was question 14. Obviously, you're sketching them both, finding the points of intersection. The area will be the top curve minus the bottom curve. So this is the top curve, the concave down one, minus the bottom curve. Make sure you put brackets there. Expand your brackets, collect like terms, and then do your integration. Okay? All right.
X-intercepts just whatever equals 0. The y equals.
Whoa, yes.